Okay, good morning, everybody. Let's get started. Review day 2. This is the last day I'm going to talk, and we're going to review logs today. And then tomorrow you have the entire day to prep and do problems and get ready for things. So let's warm up real quick. Of course, just a mix of things, graphing things, and then maybe solving some basic equations with exponentials again. Okay, so number 1 today is giving you the function negative 4 to the x plus 5. Here's number 1. And the directions say to graph it. So what you pop in your mind is always try to whittle this down to the simplest thing in your head. I see 4 to the x. That's as simple as it gets. That's an exponential with a base more than 1. So what you should be thinking in your mind is it's just going up, right? It's going to start off at 0. It's going to level, go up like that. Now, there are some differences. It's not 4 to the x. There's a negative in front. What's that do to any graph when you put a negative in front? Flips it vertically, right? So now I'm thinking in my mind, well, it still levels off at 0, but doesn't go up. It goes downish, right? And then the plus 5 on the end, of course, moves everything up 5. So this line at 0 wouldn't be at 0. For this graph, it'd be up at 5. So we're going to start there. 1, 2, 3, 4, 5. That's where it's going to level off to. And like we said, it's going to flip, and it's going to have the basic shape where it hugs the axis this way and goes, not hugs the axis, but hugs the asymptote, excuse me, and goes down like that. So something like that is what it would look like. And of course, on the test, you should plug in your calculator too and double check that it does look like that. And everything's cool. Domain, what's the domain of this thing? Should be easy to spot. Dang right, negative infinity to infinity. And the range, everybody? Exactly, very good, very good. Outstanding. Yeah, it's about that time of year where domain and range finally makes sense. 8 months later. All right, good stuff. Good job on that, guys. Number 2, it's a log one. Now, the first thing I need to review with you today, and I'll just do it right now, I guess, is what does a graph of log look like? Well, you should know, and this is the other thing, you should know what an exponential looks like. You should also know what a log looks like. Logs, by default, this is the shape that should pop in your mind for a log. So if they just say any log with a base more than 1, so say log base 7 or something like that, I'll try to only give you bases more than 1 on your test, then you should have this in your mind. Now, right at the bat, this template, what's the domain? 0 to infinity, which means you can't plug negatives or 0 into a log. Keep that in mind all the time. And the range is always negative infinity up to infinity. So that's what I know about a log by default. Specific to us, number 2, the log equation is saying log base 7 of x plus 6. So it's not quite log of x, it's log of x plus 6. What does the plus 6 do to something? Well, addition and subtraction is more about moving, just shifting things. Is it vertical? It is horizontal because it's by the x, right? So remember, horizontals are backwards. So you see the plus 6, you might think, oh, I'll go 6 to the right, but 6 to the left. So I'm going to scoot this image 6 to the left. Also, there's a minus pi on the end. What's that do to something? It just moves it down, whatever pi is. 3.14 or something like that. Yes, exactly right. So we're going to take this picture. We're going to do both of those. If you move it over 6, then this vertical asymptote, which was at 0, correct, will now be over at negative 6. 1, 2, 3, 4, 5, 6. It's always good to draw that line just because then you know not to cross it. Because that's the whole point of it, is just to know, okay, I'm going to get really close to this thing and get closer. And then the minus pi, now if it goes all the way up and down already, and I move it down pi, it still pretty much goes all the way up and down. So a nice rough sketch, just kind of the shape of the log, something like this. And again, the point of this is not to get it perfect. I don't need point by point exact things. I just need the general shape and the domain and range and things like that. Speaking of domain, what would the domain be for this? Negative 6 to infinity. Yep. Looking on the picture, it starts at negative 6 and goes on. Range, though, is still negative infinity up to infinity. Do you have any questions over that? That's kind of your review of a graph of a log anyway. Is that good enough or need more? We'll do an example problem too when the time comes. Okay, and then lastly, number 3s and 4s, we're just kind of solving some more equations. Can't do this enough. That'll be the vast majority of your test. So we have 1/4 for number 3 raised to the x plus 1. And apparently that is equal to 16 to the 3 minus x. I wonder why a 4th and a 16. Well, I wonder why. Anybody know? You can get the bases the same. Absolutely you can. Because I can write 16 in terms of 4, can't I? Yeah. But unfortunately, this is a fraction, right? You remember what you can do with a fraction? You can always flip it as long as you take the exponent and make it negative of what it was. Remember that little rule right there? So that's a good strategy to get us started. Let's go ahead and flip this stupid thing. So we'll flip the fraction, call it 4, but then we're going to multiply the exponent by a negative, which now turns it into negative x minus 1. And while we're at it over here, we can write everything in terms of 4s, can't we? We might as well call the 16 4 squared. So we got everything lined up with a base of 4 now. This is pretty good. And of course, over on the right, you have a power raised to a power. So you will multiply your exponents. So that'll be 6 minus 2x. And then all you got to do now, since you got the bases to be the same, is kind of drop the bases. Technically, you're taking a log base 4 or something like that on both sides. But if the bases are the same, the exponents must be the same. So in the end, we're getting something like this equation. Negative x minus 1 is apparently equal to 6 minus 2x. And then just moving your x's around, and your number's on one side, your x is on the other. You add the 2x over here, then 2x minus x is just x, right? And if you add the 1 back onto this side, you get 7. So apparently the answer to this problem is 7 right there. Questions on that thing? All right. In that case, there's one more, number 4. Number 4 is an inequality. If you look throughout your review assignment, I don't think there's any inequalities on it. You're welcome again. Yeah, but nonetheless, we can still do it. Because it's the exact same junk you always did. Is this going to be easy or is this going to suck? It's going to suck, right, yeah. Can't get these bases to be the same. They both got x's in the exponent. That sucks. All right, well, let's just dive in and take some logs. What's the only log I want you to use throughout the entire test? Natural log, very good. So use a natural log on both sides. And the bases don't cancel out, but that's okay. Because the whole point is the exponent will come out in front. So on this side, you have x times natural log of 3. And I'll probably change that order in a second because it bothers me to write x first. I like my number x, like 4 x's, 6 x's, or something like that. Same thing over here, the 1 minus x comes out. Make sure when you do that, if it's got more than one thing, you put in parentheses. Remind yourself that entire expression is times the natural log of 8. And what do you think you should do from here? I would agree. Let's distribute. Yeah. I'm also going to write things in a more familiar order just because this is pissing me off. So I'm going to say natural log of 3 times x because, you know, that makes more sense to me. And over here, if I distribute, I've got a natural log of 8 times 1. Well, that's just natural log of 8. And then when I distribute the natural log of 8 to the x, I got a natural log of 8 times x. And now we got it looking like this. Any thoughts on what to do now? I would love to combine like terms. And I can't combine like terms until I get them on the same side. Very good. All right, well, let's get all the x junk on the same side. Let's just move this one over here. How about that? So we'll add the natural log of 8x over. So on this side now, we'll have natural log of 3x plus natural log of 8x. And it's not obvious how I can combine those terms. Although you could undo your product property if you really wanted to. Or better yet, what do they both got in common? An x. Let's factor that out. So factoring out the x, and the whole reason we're factoring the x out is so now I have x times some weird thing, and I can just divide by that weird thing. Of course, with an inequality, you need to double check that whenever you multiply or divide by something that's not negative, I'll just tell you, natural log of 3 plus natural log of 8 is positive. So in this case, you'd be okay to divide by it. So your final answer is this. X is less than the natural log of 8 over the natural log of 3 plus the natural log of 8. But you know what I want? Even though it's not on the test, I want things in interval notation. So if this is some weird number, I'm looking for x's that are less than it. I'm looking for everything from negative infinity up to that number. So final answer, parentheses negative infinity, up to this natural log of 8 plus, or thing, whatever the heck it happens to be. I don't care what the number is. It's just some number on the number line. I'm going up to it. And that's it for that. Any questions over anything at all? It's my job to ask. Nobody ever says, yeah, but well, sometimes I do. All right, well, let's finish up this review then. So here's your LGs for the day. Boom. Continue to review for the test. over exponentials and logs. Yesterday we reviewed exponentials pretty well. Think you got a decent handle on exponentials? Today's logs. Must practice logs. Really, you got nothing on your plate to worry about now except for this review packet. 8.5, that's due on Thursday because your test is Thursday, right? You got a 2-day test, Thursday and Friday. Don't forget about that. 8.5 is due when you basically show up for the test. It doesn't, I mean, you can turn it in by the end of the day, but the point is have it done before the test. That's the point. So make sure that's done. All right, let's review Unit 8 real quick then. So Unit 8 was entirely about logarithms. All kinds of logs they introduced. Logs with different bases, common logs with a base of 10, natural logs, all kinds of junk. Let's see what's the most important things to remember. First off, of course, like I've harped on in the warm-up, the graph. Okay, very good to know what the graph of a log looks like. So the blue one on this picture is what an exponential looks like, right? E to the something or 2 to the something or something like that. The log one, like I already harped on, kind of looks like this green one. And make sure you know that the green line goes down forever, right? Your calculator won't show that. If you graph it, it looks like the log just stops, and that's a lie. So make sure you understand that concept, and it does go down forever. By default, its domain is 0 to infinity, like we said in the warm-up, and its range is negative infinity to infinity. Now here are some of the properties of logs. I'll kind of hold off on those and come back to them in just a minute. Let's just do a graph of a log real quick. We already did one in the warm-up, but do you want another freebie? Numbers 4 through 7 on your review packet are just graphs of logs. Do you want to do one, or do you feel pretty comfortable with that? 4 through 7, way back in the beginning again. Kind of put all the graphing stuff at the front. Let's do 7. That is a good one. Let's do 7. That's definitely weird. Number 7 is a trick. Not because it says log, but because the base is a little different. Usually, I'm going to give you logs with a base more than 1. This base is less than 1. So you actually might, if I could throw a trick like this at you, you might actually just want to graph it and kind of get a feel for it. Yeah, go graph it. Go graph it real quick. I mean, I could go into a whole theory land, but I'm going to try not to confuse you. Let's just see what it looks like. It does not look like a log with a base of more than 1. If you graph it, I bet you, this is the normal log when the base is more than 1, right? This is definitely the shape I want you to memorize. But for this one, when the base is less than 1, what actually causes to happen is a vertical reflection. So I bet your graph more hugs up here, does it? Okay, so should you memorize that? It'd be nice if you knew that when the base is less than 1, it's going to start up and go down. But if you do want to forget that, then just go graph it and kind of see. Now, the +9 doesn't really do much. It just moves things up 9. So in the end, this thing will kind of look like, it'll still hug this axis, only it's not going to start down and go up. It's going to go up and go down like that. So there's the picture of it, roughly. Do you all have a picture like that-ish? Okay, so jot that down, put on your little graph. And then we should just be able to look at the thing and see what the domain and range is. Domain, 0 to infinity. And range, bottom to top. What's the range always for a log? Negative infinity up to infinity. So when I have a base less than 1 or a decimal, don't freak out or anything like that. If it's something that you're not quite comfortable with, that was a good one to pick because the base is less than 1. I think everything else on here, well, 6 has a base less than 1 too, doesn't it? Oh, so what's that going to look like? That-ish, right. So use your calculator a lot, but also just use your brain for the shifts and the stretches and things like that. So that's kind of all there is to those log ones. All right, and then we moved on to section 8.2 after we talked about the basic graphs of them, and they had the properties of logs. And oh my gosh, I cannot talk about these enough. The 3 properties of how to expand logs. That means to take a log and break it into smaller parts, and also put them back together, condense them. So you have these 3 properties here, and to summarize them all, okay, if you have a log and there's stuff inside the log, multiplied or divided together, I think this quotient property kind of says it all. If you look here, the ones that are on top are positive logs, correct? And the ones that are on bottom are negative logs. If you remember that, then you can take them and split them apart, but you can also put them back together, kind of stuff. And also down here, you have this power property where if there is an exponent, you can bring it out in front, correct? Or you can always bring it back in as an exponent, going both ways right there. So I want to practice this one a lot because this is one skill that I'm kind of a little bit worried about. Let's go to numbers 24 through 27. They are all about expanding logs. And I really want to make sure we get this thing down because this should be easy points on the test. But I don't know, something in my gut tells me we might stumble a little bit, so I want to practice this thing. All right, anything 24 through 27? Anything? 25 does look good. Let's do 25. So put 25 down. The directions say to expand, and now that means that you need to get things out of the logs as much as possible. It's got a whole bunch of things. It looks really scary. What we're going to do is we're going to use these three properties to somehow break this down into smaller logs. Now, right off the bat, you see these things that are on top? If I break them up, what are they going to be? Positive logs, aren't they? And these things on the bottom will be negative logs. So right off the bat, I'm going to use a combination of the product and the quotient properties together. So here we go, one thing at a time. Okay, anything on top is a positive log. There was an x to the 22nd on top, wasn't there? So that's going to be in a positive log. There was also a y to the 50th on top. That will be inside of a positive log. The other two, what's down here? I got an e and a z cubed, right? They're on the bottom, though. So I'm not going to put plus log. I'm going to put minus log. Log of one of them minus log of the other. So that's step one when you expand things out. You use your product and your quotient properties together. And anything that are on top of your logs are positive logs. Anything on bottom of your fraction turn into negative logs. Are we okay on that? Okay. The only other thing to do is, and again, your goal is to get things out of the log as much as possible. I see things that could come out of these logs. Do you see things that could come out of these logs? Exponents can come out of logs, can't they? So what you do on the next step is you bring all the exponents back outside. So the 22 comes out. So I got 22 natural log of x. Similarly, for the next one, I have 50 natural log of y. Now, this next one, I'm trying to trip you up. Why did I put an e with a natural log? What does natural log mean? It means log base e, right? So do these cancel? Yeah, they kind of do. What do they leave you? They don't leave you 0. They leave you 1. Because this is really e to the first, right? So they do cancel. So the trick is here to see if those actually do cancel out. What's even better than a log is no log at all. I'd rather write 1 than natural log of e, so that's what you do on that. And then the very last one, well, same kind of deal. We're going to bring the exponent out. So that was a good example right there of everything that's going to happen in this section. I don't care if they're numbers or variables or whatnot. They're on top of your fraction, you make them positive logs. If they're on bottom of your fraction, you make them negative logs, and then bring the exponents back out in front. Questions on that?
Is that the answer?
That's it. I don't think there's anything else we can take out of the logs. I mean, look what's in the logs. They're like the simplest things possible. An x. Can't do anything with x. Can't do anything with y. Can't do anything with z. There's anything that's left inside the log. And we're done, pretty much. Now, if you go to 28 on, 28 through 31, that is condensing. It's the same exact thing in the reverse order. And I actually gave you steps on the condensing. Remember the condensing steps? What do? First, you bring things back in as exponents, correct? And then you shove them all back together. It's the reverse of what we just did. This process, when you expand, the first thing you do is bring the exponents, or you break them up into parts, right? And step 2 is you bring the exponents out. Well, when you're condensing, you're going the other way. Step 1 is to bring the exponents back in, and step 2 is to shove them back together into a single log like that. So let's practice a condensing one, too. Anything look particularly scary? 28 through 31. There's not that many problems, but 30. Let's do some 30. All right, 30 is actually a trick. I give you natural log of 1. This is probably the one problem on the whole test where I have a weird mix of bases. You got a log with a base of 3, you got a log with a base of 4, you got a log with another base of 3. It's just a whole thing. But this one, the point is to not, I mean, can you put them all together in a single log, condense them? That's what the directions say, right? Well, you can't put these together because they're apples and oranges. This is a log base 3, right? This is log base 4. You can't put those together. They don't play well. All the properties we have are all about the same base. So there must be some other trick to this problem. I wonder why they gave you 9 for a log base 3.
Because 3 goes into 9.
Ah, I wonder why they gave you 64 for a log base 4. So what I'm driving at on this problem is, can I write everything inside these in terms of the log base? And I can. Now this one, let's see here. Can you write 1 in terms of e? The answer is yes. 1 is anything I want to the 0 power. So I could write 5 to the 0 or 20 to the 0. But in this case, I'm going to write e to the 0 because then the natural log and the e will cancel out, right?
Then on the last problem, you said it was e to the first, so it would drop down to the 1.
Yeah, yeah. So what's this one going to turn into? Well, this is raised to the 0. So on the next step, this log in this e will cancel, just like it did up there, right? Only difference was this was e to the first, so it left a 1, right? This is e to the 0, so it'll leave a 0. Yeah, exactly. So that term actually in the front's not going to matter. In fact, that's something I harped on right in the beginning, like log of 1 is always 0. But moving right along, like you said, 9 can be written as 3 squared, correct? Anybody know 4 to a power that's 64? It is 4 cubed, very good. And similarly for the 27, that's 3 cubed. So it's not a coincidence I gave you those numbers. Be scanning for that too. If I give you like a log base 10, be looking for tens or hundreds or something that 10 to its ratio. But the idea is the same for each of these. Since the log base and the base are the same, they're going to cancel. So cancels, cancels, cancels. And the only thing left is the exponents. 0 plus 2 plus 3 minus 3, which is 2. So the answer to that whole problem is just 2. Although that was a kind of a freak problem. I'll give you one more example. That's kind of more what the style of these are in general. Let's say I gave you 2 log x minus 3 log y plus 4 log z, and I ask you to condense this. Well, the first step is to bring the things back in as exponents. So whoop, whoop, whoop. Call this log of x squared minus log of y cubed plus log of z to the 4th. And then when you put them all inside a single log, just go the other way. The positive ones go on the top and the negative ones go on the bottom. So here's a positive one. So x squared goes on top. Here's a negative one. So the y cubed goes on bottom. And here's another positive one. So the z to the 4th goes on top. So that's how you go back and forth. Are we kind of clear on that one? Okay, it's just bringing exponents back in and out and using those properties and put them into a log or not. So I do not, actually. Because what does your product property say up here? Or your quotient property? Inside of logs, they're always times and divided. Do you ever see any, look on the whole board. Is there ever anything you see a plus or minus symbol in a log? Nope, 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 nope. The outside, right? But never inside. So when you condense them like this, never put a plus or a minus. If you want to put a little dot to say times, that's fine with me. But make sure it's always times and multiply. Common thing kids will do, they'll just make up rules. They'll just put a plus symbol in there or something like that and don't do that. Good work. Any questions on that? 31. Let's look at 31. All right. That looks a little tricky. I won't do it for you, but we can talk it through together. Speaking of condensing, which means we're bringing things back inside of logs and putting them all together as much as possible, thoughts on how you would start this one? I would agree with that. So we're going to bring it in. So when I bring the 2 in, now this one's a trick. What's a square root of x squared? Oh, so I'm really just saying this is natural log of x. That was the trick on that one. Yep. After that, we'll bring all the other exponents in too. We'll finish her up. So you did step 1. You got all the exponents back inside. That's good. Now you're just going to shove them together into a log. Tell me what's going to go on top and what's going to go on bottom. X and x to the 4th goes on top. And the W's on the bottom. And that's a great answer. And then I'm going to have to dock you half a point. What could you do to make it better? Dang right it can. So yeah, never leave like an x times x to the fourth. That would piss me off. It's like leaving 1 plus 2 as your answer. I'd be like, really? Just say 3, people. Outstanding. So there's the answer to that one. Yep, exactly. I think you got a decent handle on that. Make sure you practice it, okay? Maybe go look at YouTube, you know, condensing logs, expanding logs, you know, practice it a lot. You know, it's a good skill to have. That pretty much is all there is to the hardcore stuff for logs. Now there's the common log, log base 10, right? Don't use that. That was a cute little section, but I don't want you to use that. What's the log I want you to use? Natural log. Yeah, use that all the dang time, over and over and over again to solve problems. Yeah. Log base E is natural log. That means the same thing. That is correct. Okay, that's it. Now, all I want to do is practice some problems with you, because the rest of the test is just log equation, log equation, log equation, or exponential or something like that. There's a couple in particular I'd like to talk about. Okay, you don't have a lot of experience with that. Find something where there's 2 logs in it. I don't care. Any problem in the rest of the assignment has 2 logs, like a log plus a log, or a log minus a log, or which one? 23? 33? 37? Let's do 37. Yeah, 37 is a good example right here. We've not done a lot of problems that have lots of logs floating around in it at the same time. So I want to harp on this real quick. In general, your strategy to solve any of these problems is to get a log by itself. A log, singular, right? It says 2 logs, doesn't it? That sucks. You know that skill we just practiced, condensing? There's a reason that they're teaching you to do that, because if you have a problem like this, what you want to do is put this in together into 1 log, so then you can undo it. A lot of kids are tempted to just like, what is this, all log base 2, is that what it is? Yeah. A lot of kids just do 2 to both sides, and they think that these are just going to go away. Exponential undoes a log. Does it undo lots of logs? No, so don't make that mistake. We have to put these together first, so we're going to have to condense them, which is what we just practiced, right? So the first thing we're going to do is we're going to bring these back in as exponents. We're going to shove this together into a single log. We'll deal with the amplifications later on. Oh boy, square root of x to the 4th. I might have to think about what that is for a second. This is a tricky one. And this one right here, that's log base 2 of x squared. So we're going to have to do something with this. It would be x squared. That's exactly right. Everybody know why square root of x raised to the 4th power is x squared? And if you don't, what's it mean to raise something to the 4th power? Multiply by itself 4 times. Now, you know what 2 of them are together are, don't you? That's just x, isn't it? And that's another x. So this is the same thing as x times x, or x squared. So we do have log base 2 of x squared. Good catch on that one. Nicely done. Look over on the left. Yes, they do. They're the exact same thing, aren't they? So anything minus itself is just 0. So I get 0 equals 3. Now, what does that mean when you get out nonsense? No solution, exactly. So this one had no solution. That one wasn't very satisfying. It didn't have a solution. It kind of irritates me. Find another one like that. Let's do another one. That was good, but I want something better. Thinking like
43.
Let's do 40 actually. 43 is not that bad. Look at 43. It's got 2 logs, but why is it not going to be that bad? Because they're both on different sides, right? So you're just going to do e to both sides, and then you're off and running. Let's do 40 though, because 40 is different. 40 has log base 2 of x is 5 minus log base 2 of x plus 4. I see a couple logs, don't you?
Yeah.
But I don't see a log equaling a log. That 5 jacks things up. Would you kind of agree?
Yeah.
So what you're going to do is you're going to get all the logs on one side so you can condense them together. That's the strategy. So take this minus log and move it over, which makes it a plus log on this side. Ooh. This is my favorite kind of problem right here, so definitely study it because I guarantee it'll be on your test. Now, why did I move these to the same side? Because I can put these together now. Remember, I'm undoing my product property. Remember, when two things are multiplied together, you can break them up into a log of one plus a log of the other, right? I'm going to go the other way. I can put these back together into a single log, condense them as long as I take the things inside the logs and multiply them together. Does that make sense?
Yeah.
Are you sure? Okay, I want to be like 100%, but that's okay. So we're putting them back together. In fact, we're just using that log property. Is it on the board still? Yeah, see the product property up there? Yeah, it's the same thing in reverse. Like x is x and y is x plus 4, and then you put them back together. So why do you want to get them into a single log? And please remember this strategy. I want a single log because now I can undo it with an, what's the opposite of a log? Exponential with a base of 2, exactly. So I'm going to put a base of 2 here and a base of 2 there. And by design, the 2 and the log 2 will cancel out. So now I'm left with this, x times x plus 4. And over here, I got 2 to the 5th, which turns out to be 32. I see a quadratic. Do you see a quadratic coming down? Yeah, let's distribute this out. This is x squared plus 4x. And like any quadratic, I should move the other number to the other side, set it equal to 0, and hope that it factors. Does it factor? 32? I'm thinking 8s and 4s. I'm liking that. X plus 8, x minus 4. It does factor. That works out. They multiply to be negative 32. They add to be 4. It works out great. So it looks like my two answers are x equals negative 8 and x equals 4. But there's one thing you got to worry about with log equations. Remember, what can you not have inside of a log? Negatives or 0, right? So when you get your answers out for log equations, you have to go back and check for extraneous solutions. Remember that fancy word for ones that don't work? Remember, you got to do that. So let's go try these out and see if they make things inside the log negative. How about negative 8? Well, right there, plug it in. That makes that stuff negative. Would you agree? So that's no good. Cross that out. That is not a good answer. It's extraneous. I hope 4 works. Let's see. If I plug 4 in there, I get 4. That's positive, right? If I plug 4 in here, 4 plus 4 is 8. That's positive, right? Positives are okay, aren't they? So the only answer to this problem is 4. So then write 4 again. If it's like a clean number, then just write the clean number again. That's a good question. If you want to write 4.0, be my guess or something like that. That's really all that scares me about these are problems like that, where there's a couple different logs. You got to get them on the same side first. You got to condense them, and then you can undo the log. Okay. I almost feel like we should do one more of those. Do you see any other things with a couple logs floating around, or I could make one on the fly just to see if you could do it? Which one? 36.
It would be natural log squared.
36 has a natural log of a natural log, but how do you undo any natural log? So guess what? You're going to use an e twice. Yeah, you're going to do an e to the something. You're going to clean it up, and then you're going to do e to something again. I'll make up one more on the fly to make sure you get the gist of this. Ready? Try this problem out. Last example. I'm just making this one up, so just follow along and think with me. Say I gave you this problem. Why can you not just undo the log right now? There's 2 of them, right? So I keep harping on this skill because it's freaking important. You need to take a couple logs and condense them down into a single log. Very important skill to have. Now, when you condense them, there's no numbers in front, are there? That's nice. I don't have to do that step. But when you put them together, positive logs go on top and negatives go on the bottom, right? So this was a positive log. So this x goes on top, right? This was a minus log, so the x goes on, x plus 1 goes on bottom. Always be thinking about that. If you got different logs floating around, the only time you can just undo both at the same time is if you have a log equal a log, and that's it. What jacked this problem up to 1 again, right? The 1 kind of messes things up. So how do we undo this log with a base of 2? We do 2 to both sides, right? And then we're left with this. X over x plus 1 is 2 to the first, better known as 2. Now, I don't think I'd probably give you this problem on the test because we haven't formally studied this yet. But I know what pisses you off about this fraction. It's the fraction, right? You hate fractions, don't you? How do you ever get rid of a fraction? If you don't want to divide by something, multiply by it. Well, I don't like that divide by x plus 1, do you? Let's multiply both sides by x plus 1. So I'll multiply that side by x plus 1. I'll multiply that side by x plus 1. And just like any inverses, they cancel out. Timesing by something undoes dividing by it, just like exponentials undo logs or square roots undo squares, all that stuff. And in this problem, you get x is 2x plus 2 after you distribute. And if you move some stuff around, you have x equals -2. So really just keep hitting this idea over and over and over again. If you have logs plus logs or log minus logs, don't be afraid to condense them into a single one. Then you can undo the log. You cannot undo these right now because there's 2 of them. Does that make sense? If there's 3 of them, 4 of them, I don't care. Put them all into, shove them in all into one, and then you can undo it with a relevant base. That pretty much concludes your review, unless you have any other questions. Anything else that's troubling you? All right. Well, I'll give you the day to work. Try to get most of this done by tomorrow. Try, because tomorrow's your last day to come and ask questions and say, I don't understand this or that and all that good stuff. So take it real seriously. Talk to each other. Make sure you understand what's going on. And of course, if you have any questions, I'm right here.